Okay, we are live for day 14 of Admin the Code. We're here about an hour early, and I thought I would look over day 13 and try to refactor that a little bit more. Just clean things up here and there, and that could lead to improvements in my library code that I use here. Um, so as a recap, where are we? Yes, so this is the rocks. There's a mirror in here somewhere, and this pattern of rocks is reflected against it. So I don't know if you can see here, there's this invisible vertical line, flipping those over. Um, and my approach is to take a set of points, flip them as necessary, and then we shift it over, and then we look in that intersection. We look at that intersection, and we diff those two parts against each other and see if there are any leftover tiles. If there are none, then we know that it's empty. Um, so there are a lot of points of simplification we can do here. For one, let's zoom in here. I'm starting with shifts. I'm taking all of these possible shifts, and then I'm calculating from this shift. So we flipped it over, and then we shifted it a little bit, like either to the left or to the right, to before we find out whether or not it matches, right? And then we have to do this recalculation of like, okay, how many columns were there from the shift? I think it'd be clear if I start off with the columns itself. Oh, sweet radish. Thank you, thank you. Um, I check all mirror centers and expanded outwards for each. Yeah, I mean, there's some. So like here, I'm diffing the entire thing. I shouldn't need to diff the entire thing. All I need to do is like filter, and then the moment I find uh too many smudges, then we can early cut. So that would improve that slightly. I would still do that repeatedly. But let's just start with some clarity refactors. So we're gonna make this the columns. And the columns are like 1 to area dot right. I think like the number of columns there could be. If there's 9. Yeah, I think that's what it is. So we're gonna take that, and then we're gonna do a dot find on that. Um, and then we're gonna reverse this formula here. So this is basically saying that, what is it? Calls equals width. I don't know why I say dot x range dot size. This is just width. Width plus shift and then divided by 2. That whole bit divided by 2. Um, so we want to be able to determine the amount to shift. So this should be shift equals, and I'm gonna let Copilot do my math for me. 2 times columns minus width. Okay, so let's take this and val shift equals 2 times columns minus area dot width. And then we're just gonna have a shifted. Um, yeah, flipped map p dot copy, and we're just changing the x value. Um, that works, that works. Now this intersect area, I'll continue to use that. So we can just copy that over. In fact, at this point, we can copy all of this over. Now, if we don't change anything yet, then that should simply work, right? We don't even need this down here. Oh, wait, we do have to keep the condition left diff and right diff. And we don't need the shifts anymore. And we can see the answers are still not changing, so that's good. So This bit here is basically just the center area, right? This is the part that overlaps between the two shifted areas. Maybe instead of calling intersect area, I could just call it. I mean, it is the intersect area or the center area, either way. You don't actually need to diff against the intersect of the points. This can be points dot diff by the shifted points, and this can be point diff shifted and then diff by the just the original points. Okay, so we can take out another line. There we go. Um, there is a more efficient version of size. Size is, which I should just get in the habit of using. What this does is instead of computing the size first and then checking if it's equal to whatever the other thing is, uh, it starts computing the size knowing what's supposed to be equal to, and then if there's already evidence that it can't be equal, it early terminates. That's just a good habit to get into when writing Scala. Hmm. We could turn these into filter knots, and if we did that, then we could have this early terminate, because then we can start doing like a count on that. I think we'd have to turn this into a view so that this kind of happens lazily, or an iterator. But I won't think of that just yet. I'm wondering if having two conditions is actually necessary. I mean, what if this is just true? Yeah, nothing changes. Yeah, we don't need to do the reverse test. So let's take out another line. And, we don't need to give this a name anymore. There we go. Getting cleaner and cleaner. What else? So this is a set of points. This is an area. Area.contains, and I thought I added an apply method here, which turns intersect area basically into a function because you can apply it to a point and return a Boolean. But apparently not. Yeah, I did add an apply method, right? Def apply p point returns. I don't know why that wouldn't be working. Let me see if I can just do area.apply. That works. And you can't just do that. Maybe this is new in Scala 3. And they've decided that's bad syntax. I don't know. Maybe I will call this like the center area. Or, the overlap. It's shorter. It's probably more clear, like conceptually. Okay. And like I could optimize. The thing is, I'm not even gonna be able to see the different I don't know, I could try writing dot view filter diff. We're not gonna diff that. That's gonna be like a filter not in shifted. Yeah, we don't even really see the difference there. Or if this was an iterator. Oh, iterator does not have sizes. I don't know. I don't think this is worth it. Worth the sacrifice and clarity. We'll just keep it at that. Oh, let's pull that back up. Okay, so we've dropped like 5 lines of code. Let me drop any code up here. Mm, what we can do here is now my points have a transpose method. Point.scala def transpose, or this is also swap. I think I'll define swap because swap on tuples is a thing that commonly exists. Uh, let's see. In fact, I think the base tuple might have a swap built in. Yeah, right. I'll do it just because that's expected. And transpose can just be defined in terms of swap. Just, I guess, in case you want to I don't really like having multiple names for the same thing. But here I do want to call it transpose. So points.map and transpose. Transpose area. Here's the thing, I'm having to transpose both my points in my area. I do have a transpose method now, so we can just say area.transpose. And we can say that down here. So instead of saying transpose area, we just say area.transpose. And this is small enough. I don't know. Well, yeah, we're just gonna call it swap. I'm not gonna use transpose. There we go. That's short enough. I don't mind just having that be in there. So it's points swap area.transpose. Okay. I can still have double the lines. We're like passing double the things we need for this. Um, maybe what I'll do is make like a grid type that functions as a set and is done in terms of area. This grid set thing would also like function as a set where you could take the intersections of two grids and stuff like that. I wonder if you can take the intersection of two 2D arrays. No, I don't think that's built in. If you try to intersect, it will just take all the rows that they have in common. So you'd have to like zip up all the rows and then take the intersections of those between each grid. So I do like having like a grid type of some sort, especially when you'd rather like try to think in terms of intersects and unions and diffs and whatnot. Okay, can any of this be simplified here? So we have our usual grid, area from that grid, points from the area. There's not much to simplify there. I think this is good. Okay. I'm going to commit this as well as all of the, I don't know, all of the bits I added to my points library. And we'll just do that as a little cleanup. So transpose on point. Oh, wait, hold on. We have transpose and swap. I think we didn't want transpose. Def transpose. And the thing about this transposing a point, this is only assuming you're transposing against an origin. It's similar to the rotating to like the clockwise from the point around. It assumes that you're turning it around the origin. To turn it around another point, I mean, or transpose against like another corner point, I guess you could just subtract the point, do your normal transpose, and then add a point. So when it comes to it, I can do that. But like in the future, I don't know, what would you call that point that you rotate it or transpose it around? Like the pivots? the this would be the parameter. I guess origin, you could give it a new origin around which transpose. Yeah, think about that again in the future. Um, yeah, so day 13, these are good changes. I like removing this. Um, we'll add the swap. What else is there? Let's add the supply method. Okay, this intersect stuff, I've yet to fix that. I'll just fix that as part of like my warm up for today. Um, oh, and transpose for area. Did I not already added move before? Oh, this is move for an area. Hmm. Do I use that here? Could I use that here? So we have an area. What do we do with our area? Hmm. All we ever do is take the intersection of the shifted. Oh, okay. Yeah, so we calculate the shifted area by just taking the bounding box of the shifted points, which works. That's more computation that needs to be. But like semantically, it works for me. So we'll just add that transpose bit. Hey, Copinger is in here. How you doing? How you doing? You have an invite from me. You're gonna have me click links on stream. All right, let's buy it. Let's have a look. Should I show this on screen here? This looks fancy. Fancy invite. Okay, let's pull it up. Hello, wonderful cyber resident. We, Naomio and the Copinger, I'm not familiar with Naomio, are going to try something new this Friday. A tech-focused call-in talk show. Oh, okay, I'm so down for calling in. In fact, like, I kind of want to turn my stream into a pair programming stream sometime. Folks will be able to call in, chat with us, the co-host, and if relevant, you, our guests. Streamer drama, XCV, career advice. Oh, this is fun. Yeah, I'd really like to see a lot more stuff like this. 8 p.m. Eastern until until late. Hmm. Okay. So if I don't make it there at 8, I can still be there. Have me on as a guest for our first episode. You're down just for me. Okay, okay. This looks like a lot of fun. Call in via Discord. Just have a chat. And we can chat about anything. Cool. I'll come with ideas. And I'm sure you'd be an excellent host. I remember we talked about books at some point, and I very much liked your thoughts, and I liked your what's the word? I don't know, your thoughts and your taste in books, and I think that just makes for a very good conversation. So that will be a good show. Um, everyone who's here, not many people in here right now are still in our warm up, but I might let other people know about this too. 'Cause I'd like for something like this to be successful. We need more of it. All right. That is such a great idea. I love it. Okay, so we have a bunch of stuff that we don't want to commit just yet because we haven't fixed it all. Let's look at what we're about to commit. This is really ugly. I'm sorry. I'm doing it in the terminal, and this terminal just messes up my colors for some reason. Okay, this here doesn't need to be staged. Okay, so we have the transpose, we have the apply, we have swap on the point, and we're going to commit that alongside our factors for day 13. Um, cool. So let's see, refactor 2023 day 13 and add point area methods. Oh, what's going on here? Point area methods. Okay. I think I'm happy with that. I kind of want to get it order. I suppose instead of like a mirrors function, this could just be our um. What does this return? Hmm. I could remove more of this duplication. Just put the calculation in here. So this could be like a score for some areas. Yeah, I think I'll do that. And find mirror. I don't know if I care enough to do quite that refactor. Hmm. Hmm. Let me think. Let me think. I mean, what would we do? So we do take like, all right, horizontal, got map. I guess we fold. Like we fold 0 if it's nothing, otherwise multiply by 100 plus vert dot get or else 0. Yeah, let's try renaming this to score. Instead of like getting all the errors, this can be like rock maps. That map score. Hold on, I don't think we want it quite that way. Um, yada yada 0 dot sum. Okay, and it ends to all we're really doing here is like shaving down more lines. Yeah, I can add that in. Find mirror. So this is basically parse. Here's our function for finding the mirror, like 5 lines of code, 5 lines to parse, and 3 lines to calculate the score. I like it. I'm almost happy with it. Or maybe I am happy with it. Hmm. Yeah, I think I am happy with it. Uh, um, hmm, yep. Let's add that commit as well. So what is it? We're gonna add day 13. This little diff amend, and let's push stuff up. So that all goes to this GitHub right here in the description if you're on YouTube. Hmm. And I think this leads us into fixing up some of the library code for areas that we were working on, in particular like intersect and diff. The diff isn't working quite properly. Today, today, I am armed with a pen, so we can draw stuff. In particular, let's go back to day 3. I don't think we need to have my. Yeah, let's do this. So for day 3, um, diff of 2 areas. So let's just illustrate what I'm talking about when I say that. I I'm trying to draw here. Oh, I just can't see my cursor. Hmm. Okay. So let's say we have an area. I don't like how thick that is. Sorry, it's my first day in the pen in a while. I'm just going to. That's what some of my settings have. I think to make it thinner, I just have to draw more lightly. So hey, here's an area. Um, if you diff out this area right here, then what what the result should be is this thing subtracted. So we will get like 3 little areas, right? And then like this here is all oh oh, the Copinger rated me. All right. Welcome everyone. Welcome. You're all following a great guy, I should say. I hope it is a good show. And I'm looking forward to this talk show on Friday. Mm. Do it live. That's a good motto. Um, right now, what I'm doing live is a little bit of admin code. Oh, Neo Mio. Yes, you were the co-host. So I haven't seen your channel yet. But I'll have to look you up. Can I follow you from here? I'm just gonna give you a quick follow. And I'm really curious about what this is about. Ryan Winchester, welcome. Densby, welcome. And Akira the Dev, welcome all of you. Okay, so what you just missed was me refactoring some of my day 13 code. I don't know how many of you are doing Advent of Code, but if you are, this is what's going on. This is a link to this is a code to join my leaderboard if you're competing or just stalking leaderboards. He is the one and only. Hi, welcome. Follow and thank you for the follow. Yeah, and this code I'm writing right now is there on GitHub. And yeah, so this on the left here is my day 13 solution. So I was just refactoring it, cleaning up a bit. I've got it down to under 30 lines. I started with like 44 or something. So that's nice. It feels really compact and readable at the same time. And I don't know. This is Scala, so most of you probably aren't familiar with it, but yeah, this first bit is my parsing. I hope that looks straightforward. The find mirror, I'm a little bit trickier because I'm working with sets of points, and I do some. This here is the key line where I take my points and I filter for just the points that are in the overlap area. So we're looking for mirrors, right? So we take a point, we take a grid of points, and like we flip it over, and what we're doing is trying to find where they align. So I filter them for just the part of the overlap between these two grids, and then I diff them against the other set of points that have been shifted over. And if the size is is zero, then we know that, well, diffing here is subtracting, right? So like we remove all the points from the other set that's been flipped, and if no points appear, then we know that this is a mirror image. And then just some scoring thing for like how we get the answer. Densby, you dig Scala. That's how you learn functional programming. It is a good way to learn functional programming. I think Scala is good as a learning language in general. Um, I don't know if that's not a popular opinion because Scala also has a reputation of being a tricky language, but I think you know, with the right structure, it's excellent for a first course in programming. Yeah, so I did this refactor, and that got me into working here on my standard library that I use for Advent of Code. So what I have here is an area class. So this is just a class representing, a grid, a bounding box, and it gives me a lot of, want left, right side, width, height, borders, boundaries. Does it contain a point? So I'm usually using these in conjunction with points. It's a great learning language, but you went away from the JVM after college. Mm. What do you do now? Scala, for what it's worth, is multi-platform. So there's Scala Native, which is getting better and better every year, and there's Scala JS, which is excellent and has been for a few years. Um, okay, so I have these utilities. I can get to all the points that would be contained by an area. And then I've been writing intersection, diff, union, right? So if we subtract another area from the area, what is left, right? You might get a bunch of smaller areas that constitute the remainder. And for intersection, you want just the overlap of an area. And for union, you want to combine two areas, and then that might get represented. So if I have two large areas and they overlap the corner, my thought here is to represent them as seven smaller areas. So let's see. In this case, the union of these two would be these seven squares that I'm hovering over with my hand here. Max Kruer, thank you for the follow. Let me catch up on the. You build developer tooling and infra now. That's a good place to be. That's a respectable. Um, that's respectable work. I always appreciate tooling devs and dev tooling. Making all of our lives easier. I take it. Ryan Wish, so he sent me a PNG. All right. Yeah, this is appropriate. It can sneak on you in Scala, right? Like it doesn't even have to be functional at all. You can write Scala that looks like straight up Python or Java or JavaScript, and then you can try to make it look like Haskell. But yeah, it's satisfying when people can get shit done. I agree. Hmm. Okay, so over here on the right, I have my tests for these functions I'm doing. Um, it turns out intersect is fine. Intersect is fine. Diff, I found a case. That wasn't what I expected. So the case that works so far, let's say I have this area here, and I'm diffing out. I'm subtracting this area here. Then the result there will be these 8 areas that surround that. And that was like my first goal when writing this. So I wrote a function that makes that work. Um, but where is it? Right here on the left. I'll highlight it. I have a note here. We should be using intersections. Okay, what happens when I try a diff a corner? So uh, let's look at this. So if we have a top left area, we diff out this bot right area. We're getting 0 to 7, 8 to 10. That's weird. That's very weird. So this top is going to be like our 0 to 7. Uh, let's draw this over here. Kind of start over. So we have this top left area, and that's 0 to 7. So just a square of 0 to 7, 0 to 7. Our bot right area is a square of 310, 310. And so now we're subtracting this in the red, this part here. What we expect is 3 squares, just like in here. What we're getting, let me see, show, focus, wait, hover. Okay, 0 to 7, 8 to 10. So we're actually getting, I don't know why my cursor always disappears when I go back to this app. Do I get it now? I don't have a cursor. Okay. So 0, 7, 8 to 10. 0 to 7 is our x. So we're getting this, except it's lower. So we're getting this down here. Weird. And then we're getting 8 to 10, 0 to 7. Huh. So 8 to 10 across. 8 to 10, 0 to 7. Oh, we're getting this right here. Okay. And what is the last bit? 8 to 10, 8 to 10. Okay, so we're getting like 3 in the bot right corner. That's what we're getting. This over here is what we should be getting. It's like almost the exact opposite. And now we have an idea of what's going on there. What I do. So I take our area and then the area we're subtracting. So that's A. And we get all of these intervals that represent, the left side, the center, and the right side. And we're just doing like a recursive diff on the ranges that represent this area. So we end up getting all of these. I filter out um, the area that itself gets it that is itself diffed, because we would get that back here in this case, right? Uh, why did I think we should be using intersections? Because in the case, let's say a dot x range goes far off to the right, then this diff here is just going to have a small bit, should just have a small bit to the left, right? The full range. In fact, let's do a quick test of that. So interval um 0 to 7 dot diff interval 3 to 10, right? So that gets you the interval 0 to 2. So we get 0 to 2, and then we get the original area. This looks correct. So a dot x range. Oh, so we get that, and then we get that as well as a dot x range, the part that's being diffed. We get that as well as 3 to 10. Hmm. Yeah, and that is too big. We don't want to be using that to construct any ranges. Um, I know I wrote code like this elsewhere. Let's look that up. Day 22, was it last year? 2021. Yeah, so this had a bunch of cubes in space that had to be intersected and whatnot. Um, and our diff function, other.x's. So other.x's. Oh, okay, yes, we intersect first, right? Why is there a fold? Hmm. Might rename this. Oh, Blue, welcome. Good morning. Your alarm clock was on this time. Yes, I'm already warming up. I started with a refactor of day 13, and I'm just back to messing with my standard library. Okay, so if there is nothing in the intersection, then we would just return this. That makes sense. So intersect with A, and then we fold, just return this. If there's no intersection, then there's nothing to diff out. Otherwise, we do this. I do like how much more concise this one on the right side is. I have to do this wrapping of my ranges. Hmm. If A is not equal to that interval area, we return that. Okay, that, that should fix it. Hold on, it takes issue with this. Required a list of AOC. Oh, okay, right. You need a list of area. And go back to our tests and see what's going on now. Um, the bot right area, diff top left area. Oh, you know what? Okay, this is part of the reason. In my head and my drawings, I was taking top left area and diffing bot right area. That makes it even more confusing. But in these tests, I'm taking my bot right area and diffing out the top left. And what should remain? Okay, so great. What changed here? What changed here, if I could draw it, is that these are no longer too large, right? So because we took the intersection of this big one, then we got shorter segments like that length. And now this here is gone and this here is gone. That's why we need the intersection. And that's probably what I realized last night when I was writing this, but put it away. Um, and great, we could check things on, so the area of all of that is 39. And also the area minus the area of the intersection is 39. This all looks correct. Okay. So I think with that, we are happy with my diff function. I don't think we have time to do the union right now necessarily. What part needs to be fixed? Wait, but this is true. Oh, union was broken because diff that it relied on was broken. It seems to be working properly now. Oh, this is excellent. This is excellent. Okay. So if we take the union of top left area and bottom right area, we get 7 small squares, and they're all listed out here, right? The top left, the top mid, the left mid, the center, bot mid, right mid, and bottom right corner, which is, on this drawing, it would be these 7 squares. I don't know if we drew 4 more squares here, that's the union. Okay. um, I can use this now. So we fix both diff and intersect. We have more interval tests on there. I'm going to commit these changes. Okay, unstaged changes, inside point and point tests. So we have, oh, union of intervals. Yes, I added that as part of this. And then intersect, diff, and union of areas. Um, yeah. Now let's look at point tests. And let's just add, oops, I don't want to stage that whole thing. At this part, the area intersection, area diff, and area union tests. We can stage that. All right. Add area intersection, diff, and union to AOC library. That will be good to have in my back pocket. Oh, Uh, okay. It's time to prep for day 14. So let's just make a worksheet. We're going to just save 13 as 14. Make sure things are still working. Okay. Hmm. If another grid came up, that'd make me a little bit happy because most of my library code has been centered around grids. Not that saved many lines of writing code really, but it has saved like some debugging. You make them. Well, that's the thing. Actually, with Copilot now, Copilot is good at like off by one kind of stuff, the autocomplete. So Copilot already saves me some debugging. A minute and 20 remaining. So it seems like this map is saying we've done a bunch of island hopping, and then we're not at the top. And it seems like from here, we might start going back down, going back south. Ugh, you have to excuse use my cough. I was sick like a month ago. I had a cold for like 3 or 4 days, and it cleared up. But I've been coughing ever since. Ah, okay. Just quick peek at the leaderboards while this is happening. Um, Still fifth on my own leaderboard. The room. Maybe I'll get fourth if I'm aggressive there. And yeah, same here. I'd have to be pretty aggressive to take first back on the Scala leaderboard. 2 seconds. Here we go. Day 14. All right. Oh, it's a grid problem. It's a grid problem with O's and pounds. Great. What is the question? What is the total load on the north support beams? Okay, so there are rocks on top of things. You reach a place where all the mirrors were pointing, yada yada. There's a parabolic reflector dish. It's made up of many small mirrors. Must be what provides the energy for the lava. If you focus on the reflector dish, maybe you can go. Use okay. The individual mirrors appear to be connected. In short, if you move, the platform is covered in rocks of various shapes and weights. Okay. If you move the rocks, you can focus a dish. The platform even has a control panel that lets you tilt it in one of 4 directions. The rounded rocks will roll when the platform is tilted. Okay, so we tilt. All the cube-shaped rocks will stay in place. Okay, so we have 2 different types of rocks. And we have empty spaces. Start by tilting the lever. So everything rolls north. Hmm. Okay, okay. So we'll need like a grouping function that they get like held up on these rocks. Okay. You notice that the support beams along the north side of the platform are damaged. To ensure the north platform doesn't collapse, you should calculate the total load on the north support beams. Right, start by tilting the levers that all the rocks will go north as far as they will go. Okay. First problem is just to tilt it north, and then we have to calculate the load. The amount of load caused by a single rock is equal to the number of rows from the rock to the south edge of the platform. To the south edge of the platform, including the row the rock is on. Okay, I'll have to get that math right. Cube-shaped rocks will contribute to the load. The total load is the sum of all the loads caused by all the rounded rocks. So after we move, we just calculate the distance of all of them from the bottom and sum that up. Okay, so get lines to vector. So this is our main grid. Val area equals area of that grid. Val rounded is going to be a set of point, and it's going to be area that points filter. It knows my code by now. Not quite the filter I want though. Grid of that point is equal to O. And then we have square rocks. Yeah, I'm gonna call them squared. All squared. It knows, it knows. Okay, and then for each column, we just roll everything up north. um, let's see. I'm gonna roll north along a column. Val. And do I just calculate for each of these or def? And that will be that'll be its position. So I can iterate over the point locations, right? Like in this order, or like, I mean, in any order, as long as we're going top to bottom. Or I could, yeah, and at each step, we're like updating our state. So this is like our starting state. And then, we just like look at occupied. Yeah, that could work. We could also do like a whole column all at once and sort of like group them. But if we do that, so like say a column like this, I think we have to split the ranges by these flat rocks. I think I'll do it individually. This is small enough I can do it individually. That will be easier to debug. So we're given a state. We're given a point that we're rolling. So P point rounded that point, and then we have squared, which is another set of points, and we end up with the point where it will go if there's a point to roll. So let's make that an option. Like this could also just return our next state, but we'll do like the state updating inside of another function. So this rounded will have this point subtracted and the new point added. Okay, yeah. In fact, you know what? We're just gonna give the point to where it would roll if it was there, and we'll only call this function if there's a point. And maybe that could be like an assertion of some sort. Assert rounded p. We're not gonna deal with options here. 3 minutes. I barely read the problem in 3 minutes. That guy. Okay. So now we look at the points above it. So we could use like a line, and then we find val north points equals iterator dot iterate. So these are all the points north of it, and we're gonna get the empty one. So we start with our point, and then we do dot n. It knows not take while rounded though. Let's add a take while inbounds area dot inbounds. And let's also add we're just gonna take the last element of this. So this doesn't need to be like this can be a fold left or something. And we're just gonna do that to list at last. And then take the take while oh, you know what? We're gonna drop one. No. We're not gonna drop one. So take while let's add a method here. Def occupied. So equals rounded p or squared p. And take while not occupied. Okay. And the reason I was going to drop the first one is because that one will always be occupied. So we're going to drop one. And we're going to do like a to list last option and dot get or else just p. It stays in place. Okay, we don't even need to have a list of north points. We just do that. Area.inbounds. Inbounds is not a member of area? Wait, really? Points is not a member of area. Oh wait, points iterator, right? Yada yada. We're gonna like set each of these. Take while area.contains. Or yeah. Not occupied. Oh, this should be a function on a point. Okay. Or you know what? Occupied is actually just a union of these two. So val occupied equals rounded union squared. There we go. And then now we just take all the points, area, and this is going to be like a big old fold left. Now, what order are all these points returned? The order here matters. So for y and range, so we start with the top y's. This is actually perfect. And then filter occupied. We're just gonna have another occupied inside here. Occupied. Oh, no. We're just looking for the rounded points. Okay, and the reason I just don't use rounded is because I want them in this order. Okay. And we're gonna fold left, and we start with our set of rounded and squared. Rounded and squared. Case rounded squared p n equals roll north. This is the new point. New rounded is rounded plus n. Actually, you have to subtract p first. And new squared actually stays the same. So in fact, squared is not part of the state here because it's not changing. Okay, so rounded minus p plus n. Okay, great. And squared doesn't need to be a parameter here either. But we'll leave it as such. And then what is this? It's returning a tuple? No, we just don't need new squared. And shorten this even more, rounded minus p plus n. In fact, I'm just going to take this, whatever the new point is, val final state, final rounded. I'm just going to print that. So print area.draw. If final rounded, then O, else grid P. There's more to it there. So if final rounded is, then we do O, and else if squared P, then I don't know why I'm bothering drawing this. I should just like submit my answer. I don't know why I do this. Oh, I mean, I guess this whole thing is just else grid P. Yeah. Okay, yeah, that's fine. That's fine to start. I need to make that wider. Has everything moved north? I'm not sure it has. It does not appear to have. Okay, so we have some debugging to do there. Let's use test data. So we want to get that picture. Day 14, 2023. We'll save this as example. Okay, so we're going to work with the example file now. And we can print a before and after. So if rounded, and we're going to copy this worksheet output and open up our Scratch file. Okay, so this is before, this is after. Like this looks pretty good, except just like some things are missing. I want to look at this points iterator filter rounded. And what order is that being printed in? To list. Okay, 0, 0, 0, 1. We're starting with the most northern points. 2, 1. Wait, yeah, 1, 3, 3 as our Y, 4, 5, 6, 6, 6, 7, 7, 9, 9. Okay, like that order of points is good. What I could do is like turn this into scan left so it shows all my intermediate states. And I could look at these one by one. In fact, that's what I'll do. Well, maybe. Left. Well, states. And you know what? I think we're gonna turn this to like a list. well, let's see this. The states, not for each state. Um, Print line, yes, we're gonna do that. And we're just gonna look at this step by step. Copy worksheet output. Okay, the first point we're looking at is this. We start moving things north. Oh, hold on, hold on. Wait. Just move it to the northernmost unoccupied spot, right? But wait, we move it through unoccupied spots to right before the first occupied spot, the last unoccupied spot that is north of it. I think I should zip the states with whatever's about to be moved, or whatever was just moved. So states point iterator. I don't know, maybe not quite yet. So this is the first one that should be moved, right? So the point 0, 2, 0x, 2 down. Oh, why does it start with that? That's final rounded. Okay, 0, 0 gets moved first. It ends up in the same place. 0, 1 gets moved 2, 1, 2 across and 1 down. So at some point, this 2, 1 gets moved up. Okay. It does not appear to have disappeared, though. There are too many points. Okay, let's look at that. Day 14. The number of points should always be the same. So in this, we're going to print like rounded.size. That size. Let's look at what's printed. So 18, 18, 18, 18. Oh, I mean, it is always 18. Let's look at our final state. So final rounded dot size. Rounded dot size. We're not losing anything. But what are the suspicious ones? It's like some of these at the bottom don't get moved. Let's take a look at those again. What's not getting moved? Like this one here, the one that's 2 above. So this is an x is 0 and y is 0, 1, 2, 3, 4, 5. 0, 5. Right? Now 0, 5 is one of our points. It better show up as one of our points that we're moving. Where is it here? 0, 5. It gets moved right before 5, 5. Okay, when we do a roll north here, val resting or val end. Okay, and we're gonna do like a print line, rolling p to end. Okay, and now let's copy the worksheet output. And now we have some more tracing here, right? Oh, it happens up here. That's because I did it in the final rounded calculation. You don't want it there. So rather, we want it here. Yeah. So let's copy this over. We don't need rounded dot size anymore. P to end. Yeah, this should work. Copy worksheet output, look at scratch. Um, okay, so at some point we are rolling 0, 5. Rolling 0, 5 to 0, 3. And afterwards, like, this is the result. And apparently did not move. The 7, 4 to 7, 0. Let's look at examples that did move. 0, 0, yada, yada. 0, 1 to 1, 1. And then in the next, we see that it has moved to 1, 1. Except, what is this doing here? This appears to have too many points, doesn't it? Because we've added a point. That's the only difference. Okay, so for each of these, we're just gonna we are printing the state. This is a new map. We'll give a name val new rounded, and then we're gonna print that new rounded. So print new rounded. Yeah, so that's after each move, and then new round is what gets returned. So we can take this out, and before that, I'm gonna draw my starting thing, and we're not gonna make that val. I'm just gonna do the thing. Let's scan left. Okay. And oh, I guess that does need to be assigned to something. Val states not to list, I guess. And then this is when all that happens. Okay. We have to do dot last so it doesn't print too much. Okay, we should have better debugging now. So when you roll 0, 0 to there, this is the resulting image. And then you roll 2, 1, 2, 1, 2, 0. This is the resulting image. Oh, I also want to add back the count of points. We're gonna do right here. Val print line. New rounded dot size. That's not val. We just do the print line. Okay. It says it's the same size. Did something else move too? I'm not seeing it. Let me just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I count 19 points. There's something wrong with my draw function, perhaps. New rounded dot size. We'll just add that as an assert. Assert new rounded. That size is the same. Right? There are no failures there. So if it's just an issue with my draw function, I should just submit my answer. I don't know why I spent so much time drawing this. We should just submit the answer. Uh, okay, let's go back to final rounded. Um, Final rounded dot map p, and then what's it gonna be like? Area dot height minus p dot y, and the sum of all that. 41. Is that what we get here? 136. No, I haven't calculated the load quite properly. Cube shape. The amount of load caused by a single rock is equal to the number of rows from the rock to the south edge of platform, including the row the rock is now on. So this is like 1, 2, 3. So if the height is 10, and this is going to be like p, this is going to be index 9. Um, It's not area dot height minus p dot y. I think it's just p dot y, because this is going to be 0. No, no, no. It is area dot, like, so 0 needs to be turned into 10. So if the height is 10, 10 minus 0, right? This is 10 minus 1, this is 9. And this very last row here is 10 minus 9, which is 1. Okay. So that is correct. But, oh, my final rounded isn't correct, though. And why is the size? Yeah. I count more than 18 there. 1, 2, 3. So this is 8 plus 4, 12, 13, 14, 15, 16, 17, 18, 19. Okay, we have an issue here when we're updating rounded. So val end, this is a new point, right? Rounded minus, remove the original point, right? Dot remove, dot delete. What's the function? What's the actual function name? Let's look that up. Alias for exclude. Exclude point dot include end. I fear, okay, what might be happening is we might not be shadowing something that we should be shadowing. Let's take out squared. We don't actually need that. Um, Numbers we're getting. So in here, like the calculations are correct, right? Like you would roll 0.31, the 1, 2, 3, 1. You would roll 3, 1 to 3, 0. But the image afterwards is wrong. The size of the set is correct. This is a weird bug. Okay, so like set 3, 4, 5 dot exclude 4 dot include 6. Right, this becomes a set 3, 5, 6. Let's test that with points just to make sure. So like, let's say you have the 0.34, and then we exclude the 0.34, right? And then we include Um, 6, 7. Sure. And again, this can just be like minus and plus, right? Yeah, that becomes a set 0.67. That's what we're doing. The side of the set is the same before and after. We've asserted that, and yet the drawings are wrong. The drawings are wrong. Also, there's something seems wrong about this final calculation. Um, let's do the map part of that. Oh, hold on. That's because final rounded is a set. So let's to list that. $136. Oh, okay. I mean, this works. This works. Is the only thing wrong my drawing? Oh my god, if the only thing wrong this whole time is my drawing. I mean, okay, I had to turn that whatever. I was summing on a list, on a set instead of a list. Antoine. 109385. 109385. I mean, I had it. I had it the whole time. What was I debugging? I was debugging drawings. Oh my god. Okay. The parabolic reflective dish deforms. Okay, each cycle tilts the platform 4 times so that the rounded rocks roll north and west and south and east. After each tilt, the rounded rocks roll as far as they can before the platform tilts in the next direction. Okay. After 3 cycles, this process should work if you leave it running long enough, but you're still worried about the north support beams. To make sure, you'll need to calculate the total load after that many cycles. Okay, so we have to find some point at which things start to repeat, because we can't actually do, what is that, 10 million cycles? Oh my god, if I hadn't tried to draw, I had just done the answer, I wouldn't be up at 5,000 there. How long ago was that before I started debugging drawings? Ah, silly, silly, silly. Okay. Um, this is just test stuff. We're gonna comment out the test stuff. This stuff here we don't need. Um, yeah, yeah. Oh boy. So now we we rotate. So we do a full cycle. Um, Now they'll be chunked. I have to do like multiple at a time. This here won't continue to do. Um, we can do one full cycle, see what happens. And to do this, I could like rotate my entire set, rotate the whole thing clockwise. Then we have to find like the center that we could rotate the points as well. And the area is 100 by 100, so we don't have to change the area. Let's see if for the example is 10 by 10. Okay, so we don't have to change the area at all. I'm just going to change a lot, so I'm going to commit what I have. Wait. So 2023, day 14 as solved. Stream. Man, I'm still kicking myself for not just computing the answer. Like I was there. I had it. Um okay, but we can make progress here on this part. Let's rotate def rotate a set of points. Wait. Points. And we're gonna rotate around the middle of our area. And the middle of our area is not itself a point. Hmm. And what direction are we going to want to rotate? Let me check here. So we have a cycle of north, and then we tilt them west, and then south, and then east. So we can just keep rotating clockwise, and then roll north. Rotate clockwise. Um, I think we need to plan ahead quite a bit more here. So this is going to be, how many zeros is that? 1 billion cycles, right? Like a single roll north here is order number of rounded. And then like times the number of spaces above it, which is going to be, square root of the size. Um, so that is not going to work. At what point might things start repeating? To make sure they'll survive for a while, you need to calculate the total load on a north support beam after that many cycles. I mean, suppose we do some memoizing uh, on the whole set of points. That's like a big set of points. We don't want to do that. Um, at some point, each cycle is going to repeat. After one cycle, we have that. After two cycles, whatever. Let's say maybe at some point we do a bunch of cycles and we end back in the same place. How could that be? So let's think about a case where there's only one rock in here somewhere. So at some point, I mean, let's say it's going out in a spiral, whereas, right? Um, then maybe the last arm of the spiral goes here, then rolls south, and then it just keeps rolling around in this area, right? It basically keeps moving right and left in that place where it is stuck. We could like look for places where rocks would get stuck. Like here, I don't know. There might be smaller places that just keep getting stuck. You have to be significantly smarter. Um, Still don't know why my drawings were not working. Why the last drawing didn't look correct. Oh my god, I know what's wrong with the drawings. I did, or else you print the grid. And when you print the grid, what you get is the original. Ah, remember when I was almost writing like else check if they are in um that's what it is. That's what it is. I know what it is now. Yeah, it's this right here. Okay. I mean, just for kicks and giggles, I wanna make that work. I don't think we need all of these tests here. Let's just print. So this turns into like an else if. So draw P, if rounded, then O, else if squared P, then pound, else dot, right? Da, da, da. Yeah, yeah. Part one was easy. I think I solved it in like 10 minutes, and then I didn't submit an answer. And I spent 20 minutes wondering why like my answer was wrong. In fact, it was just my drawing. My drawing was wrong. Because I decided I just like draw it first before submitting an answer. Silly, silly, silly. Okay. So this is like the original. Wait, it had an issue with that. Equals expected. Oh, def rotate. Yeah, we still haven't done that. Yeah, so this should be almost the same if final rounded. Oh, okay. So like now we would print the final state, and that looks a lot better. I'm just gonna add that. Yes, all of my drawing code. Like this is a little bit of code I wanted to write before submitting, and that took me 20 minutes. Oh my god. Um, yes, this is VS Code. Okay, so we can rotate a set of points. I think we have to at least do one cycle before we do any kind of like math. Um, and each point, it's not quite this. I think we have to shift it over first. So let's say we're rotating like a 10 by 10. I do already have like a rotate method. After we center it, but the thing is, okay, we have an even number. Um, I guess my rotate works around odd numbers. Okay. Let's just look def clockwise. Right, it's like a negative y and an x. So like the amount above the halfway point. So let's say well half equals area dot width divided by 2. We're assuming square. In fact, like you could write that as an assert area dot width equals area dot height. Just in case, okay, breaks that code. Okay, and generally for rotating clockwise, you take negative y and then x. So we look at like how far above uh, points that map. So it seems half plus p dot y minus p dot x. Okay, so let's say we have a point. We have a pen today, so we can draw this. Um, okay, and let's zoom out a little bit so our drawings are thinner. Um, okay, so we have like our origin here, right? And let's say we have a point here. To rotate clockwise, we end up going here. Um, but this isn't the usual, like, let's say that's 4, 1 normally. Let's say this is 0, 0, and this here is 8, 8. So our middle is actually at like 4.5. So our middle is 4.5. So this here is actually, let's say normally that would have been a 3 across and 1 up. Uh, let's think of actual, okay, change color here. So there are, oh, no, nope, we want a new color. Do I have to click that? I don't know. Okay, there we go. So 1, 2, 3, 4. What does each thing get translated into? So let's say we had this point here. Well, I guess we're starting from 1, 1. Let me look at our grid here. So our area is 0 until 100. Um, area dot width. Area dot width is 100. So that'd be like 0 until 8, which is to say 0 to 7, or 1. So we're gonna have this be like 1, 2, 3, 4, 5, 6, 7, 8. So let's say this point here, this red point, is 7 across, and then 1, 2, 3, 4 down. 7 and 4 down. And that goes to, what's going to be the equivalent here? 1, 2, not there. We'll put in here. That becomes 5 across and 7 down. And rotating it further, right, we get 1, 2, blank, whatever, and 1, 2, blank, whatever. The stuff that should all be in my library. I had talked about I talked about this earlier on stream when I was writing my library. I was like, oh, my clockwise rotation of a point assumes origin. I should be able to rotate around an arbitrary point. And my solution was like, oh, we could just subtract the point, rotate, and then add the point back. But now you have like a 4.5 point, which doesn't quite work how I'd expect. Right, my points only work on integers. Okay, so this becomes, let's see, we keep going, and this becomes 2 across and 5 down. 2, 5, which then becomes 4 across and 2 down. Okay, and the patterns we're seeing here are X and Y. So y becomes 4 should play into this somehow. So it's like 7 minus 4. So we know like x will depend on y somehow. Not quite. Wait, does it? I guess x does become y, right? I'm not convinced that's exactly how it will work. So here x is becoming y. So now for the y part, it's usually like y becomes negative x. So for what happens to this to become happens to 4 to become 7. And then wait, so 7 here just goes to 7. What happens to 4 to become 5 rather? 4 becomes 5. These middle pieces. 4 becomes 5 somehow. 7 should be related to 2. 5 should be related to 4. And 2. 2 becomes 4. So let's see. Um, so like 4 minus 4 plus 1. I mean, if I were doing this, yeah. I'm doing that because I already had like a clockwise method. And then my clockwise method only works on origin. Um, what I could do, what I could do is like inflate the points. Oh, hold on. Like this works if we make this 0, then it just becomes like x becomes y and y becomes negative x. But like the right piece has to be 0. And there's like a rounding thing going on here because this middle point is actually like 0. It's like a 0.5 kind of a thing. Um, yeah, I was just gonna rotate them and reuse my north function, but you are right. This is taking me too long. We're just gonna copy paste this. And do south, east, west. Or rather, we have a direction. The def roll, we're gonna just call this def roll. Direction. And whatever our rounded is. And instead of iterate p.n, we do like dir.move. Dir.move. Move takes more parameters. There we go. And then, roll north in this case would just be roll north p, or rather roll dir.north p rounded. Good point. Thanks for taking me out of that rabbit hole. Okay. So now let's just do like a cycle. So I'm not gonna rotate. Def cycle, and this is where we roll each in order. Um, I guess what does a cycle look like here? This is a cycle. This is roll all north. Can make this a function like that. So def roll all north. Area that points iterator. Okay, this is the part of the reason I wanted to I wanted to rotate them. Because this points iterator like accidentally works well on north. Because it starts with points at the top. Uh I'd have to like resort these. So, so this has a start set of points. Start rounded. Let me do our points iterator, filter rounded. My first version of this, we're just going to do an inefficient version just so that we can do a few cycles and try to find some patterns that will help us think about how we math our way through part two. Um, right, and then roll all west, or rather, just roll all in some direction. So area dot points iterator dot to list dot sort by oh, sort by like northmost in like the north case. So this sort depends. Um, def sort by dir, and this will depend on the dir. So dir match. Oh, Vita, thank you for the follow. Yes, yeah. Brute force is. I don't think that will work at all. In fact, I think the solution is not to simulate a billion cycles at all, but rather to find a point at which things start to repeat. We do a cycle detection on cycles, on like the meta cycles of cycles. uh, okay, so this is our roll all north function. In that case, we just do like the points iterator. Oh. So we have a set of points, and in north, we just sort by. Oh, we need to be sorted. So let's make this like a list. Points list point. In this case, it's points that sort by that y. So 0, the northmost, will happen first. For south, it's just negative that. For east, eastmost is the lowest x. The points that sort by. I don't know why Copilot isn't coming in here. Points that sort by negative x. Okay, so let me roll all. We're gonna do start that to list that Oh, we're gonna sort that by direction. Sort by dir. Pass along the dir. And you don't even need to do filter around it anymore because we're gonna assume that's what we're being given here is rounded pieces. So we're just gonna do like a fold left. This whole thing, that fold left, and we start with our start. And these are rounded pieces, end case, rounded minus p plus end. Okay, so we have our roll all function, and then now we have a cycle. Let's make a cycle function. Def cycle. Um, Start is like a set of points. I believe it. I believe it. Okay, so we're gonna take all of our directions. List dir.north, dir.west. Right, it's north and west and south and east. Fold left with our start, and then we take our rounded points direction and roll all in that direction. I think I should just change order of things in my roll, my sort by direction, and then my roll all. Okay, so fold left, start, roll all. So I'm gonna do is I'm gonna go to the example. I'm just gonna print a few cycles, make sure it looks correct. Oh, Rimu, rating with a party of 15. Thank you, and welcome to the stream. Okay, so I'm working on part 2 of today's problem. I assume, Rimu, you're working on advent of code, and that you have solved part 2 or given up way too early. Wait, what happened here? Dir.move is not a member. Nonsense. Dir is my move is part of dir. That's a weird compiler error. Fair enough. Keep the advent of code torch burning. Oh, actually, give me just 1 second. All right, so we have a little bit of an emergency. I'll keep thinking about this problem, and I'll have to continue another time. So whoever's still here, we should raid someone else. Um, I'll just do that real quick. Oh, nope. So Twitch admin code. And then maybe after this is handled, I'll go um, back online. Yeah, let's raid Alka. Chi-Chi? Chi-Chi's already done. Surely Chi-Chi's already done. We'll go to Alka. Just see someone else finish this problem. And then maybe Alka will make it to Chi-Chi by the end of the night. All right. Um, Thanks all of you who are still here for waiting so long. I, I do appreciate the patience. But have a good night. Maybe I'll see you more later tonight, and if not, we can finish up tomorrow.